In this video, I will be teaching you how to solve modulus inequalities graphically. So let's say that we have the expression, the absolute value of 2x minus 1 is greater than 3. So when we represent these graphically, we're essentially just creating an image so we can see where our graph is greater than 3. So we already know how to graph modulus equations. Firstly, we create our axes. So this is our y-axis and our x-axis. You can label this as well. It's 1, 2, 3, 4, 5. And we start out by graphing y is equal to 2x minus 1. So when 0, y is 0, then we get 1 is equal to 2x, x is equal to 1 over 2. So this is 1 intersect. And when x is equal to 0, then y will be equal to negative 1. So this right here is negative 1. Now we can draw our graph. So it goes like this and then goes below 0. Now we need to reflect our graph in the axis. So that should look something like this. And this on the right is the graph of y is equal to 2x minus 1. And on the left we have the graph of y is equal to negative 2x minus 1. So now we want to find all of the points where this graph of ours is greater than 3. So let's draw out our axis. 1, 2, 3. So all of the points where our graph is higher than 3. So that'll be everything over here and everything going up this way. So what we need to do now is we need to find the points of intersect. So let's first find this one. 2x minus 1 is equal to 3. 2x is equal to 4. Excuse me, x is equal to 2. So next we want to solve for this point right over here, where the graph or the line negative 2x minus 1 is equal to 3. So negative 2x minus 1 is equal to 3. We get negative 2x plus 1 is equal to 3. We get 2x is equal to 1 minus 3. Then we get x is equal to negative 1. So this right here is negative 1. And this right here is 2. So our graph, or the modulus equation 2x minus 1, is greater than 3 from this point onwards. So from 2 onwards, going up like this, and oops, from this point onwards as well. So going down from, yikes, going down from negative 1. So all of these values and all of these values. So through this, we can say that x will either be greater than 2 or x will be less than negative 1. So what we basically just did is we graphed the absolute value of 2x minus 1 and looked at all of the points where it was greater than 3. Let's look at another example where we have absolute value functions on either side. So let's say that the absolute value of 2x plus 1 is greater than or equal to the absolute value of 3 minus x. So it's a very similar idea over here. We're just going to graph both of these graphs in this case. So we'll graph 2x plus 1 and 3 minus x, and we will find all of the points where the absolute value of 2x plus 1 is greater than or equal to the absolute value of 3 minus x. So let's draw our axes. So our y-axis and our x-axis. So let's first graph 2x plus 1. So y is equal to the absolute value of 2x plus 1. So we start by graphing y is equal to 2x plus 1. This gives us, when y is 0, then x is negative 1 over 2. So that's right about there. And when y is equal to and when x is equal to 0, then y is equal to 1. So those are our points. So something like that. Going down, and then we reflected in our axis. And this right here is the graph of y is equal to 2x plus 1. And this is the graph of y is equal to negative 2x plus 1. And that's just because it's the reflection. Next, let's draw the graph of y is equal to the absolute value of 3 minus x. So first, let's graph y is equal to 3 minus x. So when y is equal to 0, then x is equal to 3. So y is equal to 0, x is equal to 3. And then when y is equal to, or when x is equal to 0, then y is also equal to 3. So our graph will look something like this. Intersects with this graph over here and is reflected in our axis like this. Let's draw the arrows. And this graph over here is the graph of 3 minus x, and on the other side it is negative 3 minus x. This isn't the neatest diagram, but it should do. So now what we want to do is we want to find all of the points where the absolute value of 2x plus 1 is greater than or equal to the absolute value of 3 minus x. So that would be from here onwards, and over here, that would be from this point onwards. I should do that in a different color. So that would be from here onwards, going up. And over here, that would be from here onwards. And these are the points where it has a greater value. So now we just need to solve for this point and this point in order to get our final answer. So at this point, the graph of y is equal to minus 3 minus x. So solve algebraically. So y is equal to, or the graph of minus 3 minus x intersects with the graph of negative is equal to negative 2x plus 1. You can't really see it over here because of all the circles. So we get minus 3 plus x is equal to minus 2x minus 1. From this we get 3x is equal to minus 1 plus 3, which is equal to 2, and x is equal to 2 over 3. So at this point, right here, x is equal to 2 over 3. This intersection I also apologize. This is the graph of 3 minus x, and this is the graph of negative 3 minus x. So we just found this intersection point. So now let's see where the lines 3 minus x and negative 2x plus 1 intersect. So we get 3 minus x is equal to negative 2x minus 1. This gives us x is equal to minus 1 minus 3, which is equal to negative 4. So this value right here is negative 4. And remember, right now we're trying to find all of the points where the absolute value of 2x plus 1 is greater than the absolute value of 3 minus x. So let's clean this up a little bit. Hopefully it looks better. Oops. There we go. Now, from this point onwards, the graph of the absolute value of 2x plus 1 is greater. And from this point onwards, the graph of 2x plus 1 is also greater. So from this, we get everything here onwards. So everything, so x is either greater than or equal to 2 over 3, or x is, so from negative 4 going onwards, x is less than or equal to negative 4. And this is our final answer.